Let's do a dihybrid cross. Now we're looking at two traits. So we're looking at fur color and we're looking at length, long versus short hair. Okay, so for guinea pigs, black fur is dominant to white and short hair is dominant to long. So let's set up that key before we go much further. Again, now we're looking at two things. So fur color, and just use big B equals black, and little b would represent white. Okay, so that's one of the two. And the other one is for length. So short seems to be, I'm going to use capital L for short, which is dominant to little l, which is long. Okay, so short hair is dominant over long hair. So that's two traits, dihybrid. A guinea pig, so now I'm reading about the cross, a guinea pig that has white fur and long hair. All right, the only way to have white fur, so here's the parents. The only way to have white fur would be two recessive alleles, so little b, and long hair, same thing, little l. And that one is crossed or is mated with a guinea pig that is homozygous for black and homozygous for short hair. So homozygous for black, short hair. So that's all dominant. All right, so this is, the first one's pretty straightforward. Predict the phenotype of the F1 generation. Well, this is the parental, and this parent only has recessive alleles, so the only gamete this parent can produce are gametes with little b, little l. And then this parent only has dominant alleles, so again, all their gametes will only have big B, big L at the end of meiosis. So let's put that in standard form, big B, big L, little l. Okay, so this is the genotype, but please be careful when you're reading this right here. Phenotype. What is the physical appearance of the F1 generation? And this doesn't tell me the physical, but it does tell me the genotype. And from that, I can figure out the phenotype. So if it's big B, big L, little l, then I know that it is going to be all F1, all will be black and short. This is a phenotype. Okay. So now that I've established the phenotype and the F1 generation's genotype, it says if two F1 individuals are crossed, predict the phenotype ratio of the F2 generation. Okay, so here's my genotype for F1. I'm just going to get rid of that. Okay, so, and I'm going to cross two of these. So let's make sure we got this right. Big B, little b. There we go. That is one parent from F1 crossed with another from F1. Okay, and I hope you recognize this. This is a classic Mendelian two dihybrid heterozygous for both traits. Individuals are going to cross, and when you see this, you should automatically say, oh, that's going to produce a 9:3 to 3:1 ratio for the phenotype. So what does this actually mean? It means that anytime you see a dihybrid where both parents are heterozygous for both traits, you can expect this ratio. So that means 9 of the offspring will have the dominant trait. So 9 will be 9 out of 16, right? So 9 will be black fur and short hair because those are the two dominant traits. 3 will have a dominant and then the recessive trait. So black fur, black short fur, and black long fur would be the dominant recessive combination. The other dominant recessive combination would actually be the recessive dominant. So we would have white, so that's a recessive, and the dominant short fur. And last but not least, white would be that the two recessives, so white and long fur. Okay, so that is what you could expect. You can do the big Punnett square. It's a 4x4. If you don't remember how to do that, keep watching. For those of you who need a reminder as how to do a dihybrid Punnett square, because maybe it isn't this, maybe it's something else, I'm going to show you how to do that right now. So let's just go down here where we have some space. So again, we're going to start with the parents and dihybrid for fur color and fur length. So how do we do this? All right, we start with parent one and we determine what would the gametes be after meiosis. So this parent, big B, could end up in a gamete with big L. That's one possibility. Or big B could end up in a gamete with little l, right? So that's the other possibility. Or little b could end up in a gamete with big L. Or little b could end up in a gamete with little l. So these are the four possible gametes that we have from parent one. And again, since parent two happens to be the same, it would be the same. So just to prove that this 9:3 to 3:1 ratio is what you get, I'm going to keep it this way. So parent two, it's the same gametes. So we're doing a 4x4 Punnett square, right? Four possible gametes from parent one. And then in this case, it just happens to be the same four gamete possibilities from parent two. So let's go ahead and insert a table. And again, it's going to be a 4, 1, 2, 3, 4. But you actually need 5 because we have to do 1, 2, 3, 4 for the other parent. Okay, so this just stays kind of blank and just ignore it. All right, so parent 1 will go across the top. So again, what are the options? And I like everything to be centered. Okay, so the option from gametes from parent 1 are going to be big B could end up with big L, or big B could end up with little l. Oh, I guess the whole thing's highlighted. Sorry about that. Okay. Or little b could end up with big L, or little b could end up with little l. And again, parent 2 on the side happens to have the same gamete combination. So just repeat that. And let's see what happens. So now we're going to fill in all the possible babies. So let's assume this is egg and sperm. If they unite, you get this. Egg and sperm, if they unite, you get this. Egg and sperm, let's assume you get this. This could happen in fertilization. We just don't know. This could happen. You see how I'm doing this, right? Big B and big L would fuse with big B and little l to give me this combination. Big B with big B and little l with little l. And there's that 1 in a 16th shot of getting the recessive trait. Okay, so again, black short fur would have to have a big B at least, right? And a big L. Anytime, because it's dominant. So that's this one. That's this one, this one, this one. So this whole row, I'm just going to make yellow. Okay. And then, yep, this one, not that one. Okay, yep. And nope. Yep. And yeah, I should have done that one too. Nope. Nope. Yep. Nope, nope, nope. Okay, so there we go. There's our 9, 1 in yellow, 4, 5, 6, 7, 8, 9. There's our 9 that are going to have the phenotype of black short fur, dominant traits. Okay, so now black fur, long was the recessive. So black is a dominant with something else. And then we have to have that to get the long fur since it's recessive. So, yep. Let's just make that one red. Yep. And yep. So there's my 3. All right. White and short fur. So white, it'd have to be this. Short fur would be that, right? Anytime there's, okay. So we'll just leave that one white. Leave this one white. And let's leave that one white. And then, of course, white with long. That's my one little one there. So I'm just going to make it kind of grayish. Here we go. So 9 to 3 to 3 to 1. And that's how you do the dihybrid Punnett square.